Alright, so last section. Okay, so this one's kind of just a combination of, honestly, all the sections. So you'll have to do a couple things. So if we had a triangle, and it's going to say to do a translation of x plus 5, y plus 1, and a dilation of 2x, 2y. Okay, so -4, 1, -2, 2, and -2. Oh, it shouldn't be -1, it should be +1. So we have A, B, and C. Alright, so translation x plus 5, y plus 1. So every point, 5 to the right, in positive x directions to the right, negative would be to the left, and then up 1. So the A point, 1, 2, 3, 4, 5, up 1 would go there. And then the C, 1, 2, 3, 4, 5, up 1, and the B would go like that. So that would be our C prime, B prime, and A prime. So what I think you should do at this point is write those coordinates down. So the A prime is 1, 2, B prime is 3, 3, and C prime is 3, 2. Okay, and the reason for that is when we do the dilation, it means times 2 of each of those numbers. So it's just much easier than looking at the graph and trying to do a times 2. So the dilation part, we're going to do times 2 on all these. So I'd have 2, 4, 6, 6, and 6, 4. So 1, 2, and then up 1, 2, 3, 4. And over 1, 2, 3, 4, 5, 6. Up 1, 2, 3, 4, 5, 6. So probably there. 1, 2, 3, 4, 5, 6, yeah. And then 6, 4 would go there. So the red part, is our answer. Okay, so I don't think those are really all that difficult to do. So it's just a matter of taking the time to plot the points out. Okay, so to me, like, that's the easier part of this. Okay, 4 of them like this, where it's going to tell you a translation and a dilation, or a dilation and a reflection, or a rotation 90 degrees and a dilation. Okay, so this is a good section to help review translation, reflection, rotation, because those are going to come up. Okay, and then you're going to have 2 that there's pictures already graphed for you, and then you're going to have to say what 2 things are happening. Is it going to be one of them will be a dilation, but is it going to be a dilation with a translation, with a reflection, with like whatever? Okay, so those are nice because it's already on a graph. Kind of the harder part is to go kind of the other way around. So where you have a graph and then you got to figure out like what's the is it a translation and a rotate and a dilation and all that kind of stuff. So let's look at one of those. All right, so if we had so that one to start with. And then this one to end with. So describe a similarity transformation that maps trapezoid ABCD to let's go W X Y Z. So here's the thing, when it gets smaller or bigger, you're going to have to do a dilation. So you know that's going to be part of it. The other thing that I look at is these are like pointing in opposite directions, if you will. Like, you know, the C part is the point and the Y part is the point, if you want to look at it like that. So the C is kind of pointing to the right and the Y is pointing to the left. So whenever you have them pointing in opposite directions, that's going to be a reflection. By reflecting it, you'll get them to point in the same direction. Okay? And so I want to reflect it. So I want to do a reflection like this way. So I'll get a reflection over the y-axis. So if I do that, because this C point is on the y-axis, that one is simple. It doesn't move at all. It just stays there. the D1 is 6. 1, 2, 3, 4, 5, 6 to the left, so I go 6 to the right. And then the B1 is 3 to the left, so I go 3 to the right. And the A1 is also 6. Okay, and so I'm going to try to make this, because it's going to go right through the middle. So at least they look, now they look the same. They both kind of point to the left, the blue one and the green one. So this would be like B prime, A prime, D prime, and C prime. So then now, and in this particular one, we kind of catch a little bit of a break. How much closer to the center is the green one compared to the blue one? So if you look at down the y-axis, the green one goes down 1 and the blue one goes down 3. So we have a dilation because it gets bigger or smaller. And the way we write our dilation was like that. And then I said the green one goes down 1, the blue one goes down 1/3. If it was the other way around, if we were going from the green one to the blue one, the picture's getting bigger, so I put the bigger number on top, and I would just say 3/1 or just 3. So the other way that you can, like let's say they're not on that line where it's really easy to go 1 and then 3. Okay, so here's another way that you can do this. How do I get, and so I'm gonna look at this X point and the B prime point, because those are the ones that go together. How do I get from the origin to X? Well, I go to the, that point is 1, 1. I would go to the right 1 and then up 1. Okay, and how do I get, and what's point B? So this is point X. Point B is 3, 3. I go over 1, up 1, over 1, up 1 again, over 1, up 1 again. I had to go over 1, up 1 3 times. It's also right here in the coordinates. You can see the 1/3. Okay, so if you looked at any of them for that matter, look at point Z is 2, -1, and point D prime is -6, or excuse me, why did I say -6? I said negative because it went down, but 6 and -3. Do you see right here? If I just wrote 2/6, that reduces to 1/3. Or if I looked at this one, -1 over -3 reduces to 1/3. So there's several different ways, you can see the 1/3 right here on this top part, of how you can come up with the fact that the dilation is 1/3. Okay, so you'll have 4 problems like the very first example I did, like this one that I already did. And then the last 4 will be to determine whether the polygon with the given vertices are similar. Use transformations to explain. So it just, can you match them up like I did on this one? So it gives you the coordinates already, and then can I make it match up? And I will tell you, 9, 10, 11, 12 are those problems. 2 of them, the answer is yes, and 2 of them, the answer is no. And the answer is no because the scale factor is different. Okay, so the lengths of sides like don't match up correctly. All right. Okay, so give those a shot. The first 4 should be the much easier type of problems, and the other ones are definitely a little bit harder. Okay, but go back and, it's going to hopefully go back and force you to review your translations, reflections, and rotations, which is a good thing. Okay, all right, have a good rest of your day, and we'll see you tomorrow.